Hello. So for this, I'd like to do some really simple introductory questions on acceleration, how to use the formula, and I'll do some more complicated ones a bit later. The first question says, a car accelerates from 4 meters per second to 10 meters per second in 3 seconds at constant acceleration. Find its acceleration. So we've already said that the formula for acceleration is the change in velocity, how much your speed changes, divided by how long it takes to change. So v minus u out of t. So v is the final velocity and u is the initial. So what's the final velocity? 10. Initial is 4, so we subtract 4, and then we divide through by 3. 10 minus 4, that's 6, divided by 3, that gives us 2. And so the acceleration is 2, but we need to put some units here. We'll say it's 2 meters per second squared, something like that. Then a car accelerates from rest to 10 meters per second in 4 seconds at a constant acceleration. Find its acceleration. So again, we're finding acceleration, so just use A equals v minus u out of t. So the concept of rest is quite an easy one. Everywhere you see rest, that just means you're at 0 meters per second there. So let's look at this. We'll say the final velocity accelerates from 0 to 10, so the final should be 10. Then we're subtracting 0, and it took 4 seconds. So say 10 divided by 4, which is actually 2.5 meters per second squared. Make sure your units are always correct. An aeroplane accelerates at a constant rate of 3 meters per second for 5 seconds from an initial velocity of 4 meters per second. Find its final velocity. So this time we're not looking for acceleration. We've been given the acceleration right there. Accelerates at that constant rate. We've been given the time, and we've been given the initial velocity. Now I could always substitute and make it work. A equals v minus u out of t. We could substitute. The a is 3, the v starts from an initial velocity of 4. We were trying to find out the final velocity, so we can leave the final velocity as v because we don't know what final velocity is. Minus what's the initial velocity? That's 4. We're dividing it by 5 seconds, and we need to find the v. So we can multiply this side by 5 and put some brackets here, and this will cancel with that. Then we can also multiply that by 5. So to have 15 equals v minus 4. If we get the 4 to this side, we'll say v is equal to 15 plus 4, which is 19. So initial velocity is going to be 19. But there's a method I prefer that you also learn the formula that has v as the subject. So if I have a equals v minus u out of t, if we multiply both sides by t, we'll now have v minus u, well the t's are now cancelled out on this side, is equal to, let's write this as at. Could now get the u to the other side to isolate the v, and on this other side it will be a positive, so we'll have u plus at equals v, or v equals u plus at. And how could we use it here? V is the final velocity, u is the initial velocity, a is acceleration, and t is time. Let's see how we would use it here. So let's see, the final velocity, that's what we're trying to find. So v equals the initial velocity, which is 4, plus 3 times 5, which is final velocity, which is 4 plus 15, which is 19. And this gets us to the answer a lot faster. Let's have some units. 19 meters per second to the power negative 2. Those will be our units. Then we've got this question. Now this one I'd prefer maybe we draw it. A car decelerates at a constant rate of 2 meters per second. So we need to pay attention to this. It's decelerating at a constant rate of 2 meters per second. So that means that we cannot take the acceleration as 2. Because if you're starting out at 6 and you take the acceleration as 2, that means after 1 second you're going to add 2 meters per second of speed. So if the car is moving a bit slowly, it will now move a little bit faster, then 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 a little bit faster. But as we know, they told us that this car is actually decelerating, which means it's slowing down. So if it started out at 6, we should not be, the speed here should not be increasing, it should actually be reducing. This is just a hypothetical, it doesn't actually start out at 6. So it should have 6, 4, 2, then 0, so it's actually stopped. -2. What would this actually mean? We've talked about this. So 0 means you're at rest, and a speed of 6 means you're moving at 6 meters per second in that direction. A speed of -2 doesn't mean that you're not moving, it means you're actually moving just in the opposite direction at a speed of 2 meters per second, but just in the opposite direction. So let's work on this question here. A car decelerates at a constant rate of 2. So what I'm going to take that as a positive, we're going to say it has an acceleration of -2. And then that's the acceleration. And then time taken is 3. And the final velocity is 8. So let's put this all in our formula. Acceleration equals velocity at the end minus velocity at the start, or initial velocity, divided by the time taken. The acceleration is not 2 but -2 because it's slowing down, is equal to v. What's v? We don't know. That's what v is actually the final velocity. We do know it's actually 8 minus the initial velocity, which we do not know, divided by the time taken, which is 3 seconds. Then we can just work this out. Multiply by 3 there and multiply by 3 there. So we have -6 equals 8 minus u. If we move the 8 over to the other side, we'll have -14 equals to -u. And then u will be 14. And what is u? U represents the starting speed. What was the initial speed? And how do we measure speed? We measure speed in meters per second, like that.